Welcome to the Copperfield Electric Podcast. It is absolutely fantastic to have you with us today.
Great to be here.
I was sitting at the kitchen table this morning staring at my bank statement, specifically that line item for the electric utility, and I had that moment of sheer, utter confusion. You know the one I'm talking about?
Oh, I know it well. It's the homeowners double take.
Exactly. You look at the number, then you look at the thermostat on the wall, then back at the number, and the math just doesn't add up.
Right.
You start doing this mental calculus like, okay, we didn't run the AC that much, right? And I swear I turned off the lights in the hallway.
It's a universal experience. We immediately start profiling the appliances in our house.
Yeah.
We treat them like suspects in a crime lineup.
Yes.
We blame the dishwasher for running too long, or we glare at the air conditioner like it's a personal enemy that's stealing from our wallet.
Right. Or we turn into our parents and start yelling about bathroom lights, even though, and I looked this up, an LED bulb costs practically pennies a year. We look for the culprits we can see.
We do.
But here's the hook for today. What if the thief is invisible? What if the reason the bill is so high isn't just because you're using energy, but because your house is actually bad at moving that energy around?
And that's the fascinating premise in exploring today.
Yeah.
The idea that the brain of your home, that gray metal box in the garage or on the side of the house, might be actively costing you money just by existing.
The electrical panel. It is the one part of the house I frankly try never to touch. I see the warning stickers and I just walk away.
As you should.
But today we're going to touch it, metaphorically, of course. We've pulled two really distinct sources to help us unpack this.
We did.
First, to get the science and the economics, we have an article titled The Impact of Upgraded Panels on Monthly Electric Bills by Renee Hernandez, dated January 20, 2026.
And that article is a great read because it moves past the standard safety warnings, which are important, obviously, and really dives into the physics of energy waste. It treats the electrical panel as a financial instrument, not just a safety switch. Most people never think of it that way.
Exactly. And then, because theory is great, but we all live in the real world, we're grounding this deep dive with data from Copperfield Electric.
Okay.
They're a local, family-owned, 24-hour electrical service based right here in Orange County, California.
And bringing in that local layer is actually really important here.
Why is that?
Because electrical grids, climate demands, home construction, it all varies wildly by region. A panel struggling in Florida, humidity faces different issues than a panel dealing with, say, the dry, high heat load of an Irvine summer.
A good point.
So looking at Copperfield's approach helps us make this real for anyone living in Southern California.
So our mission today is to kind of connect those dots. We want to explain exactly how a dusty box of breakers from the 80s wastes your money.
And why upgrading is essential if you're even thinking about solar or EVs.
And then look at the who and how of solving it locally.
It really comes down to redefining efficiency. We're trained to think efficiency means buying an Energy Star fridge.
Right, or a smart thermostat.
Exactly. But if you plug that super efficient fridge into an inefficient distribution grid inside your walls, you're still losing the game.
So it's the infrastructure.
It's the infrastructure, not just the appliance.
Okay, so let's get into the why. The Hernandez article makes a claim that honestly stopped me in my tracks. It says older panels, like from the 80s or 90s, which is what most of us have, are often inadequate. But then it calls this an energy waste issue. I always thought if a panel was inadequate, the breaker would just trip. Click, off, done.
And that's the catastrophic failure mode. That's the safety mechanism doing its job.
Right.
But Hernandez is talking about what happens before the breaker trips. Think about the basic physics of electricity. It flows through copper and aluminum.
Okay.
In an old panel, you have connections that have loosened over 30 years of thermal expansion and contraction, or maybe components of
Oxidation, like rust, basically.
In a layman's sense, yeah.
Okay.
It creates resistance. And in physics, resistance is the absolute enemy of efficiency.
Okay, so what happens?
When you try to push a high electrical load through a system with high resistance, that energy has to go somewhere. It can't be destroyed, right? It just gets converted.
Converted into what?
Heat.
You mean literal heat, like the box gets warm.
Exactly. It's called joule heating. You are pulling electricity from the grid. The meter is spinning. You're paying for every kilowatt hour.
Right.
But a percentage of that electricity is just turning into heat radiating off your bus bars in the garage. It isn't lighting your lamp or cooling your beer. It is just warming up the metal box.
That is incredibly frustrating. It's like buying a gallon of gas and spilling a cup of it on the driveway every single time.
Perfect analogy.
Yeah.
And the Hernandez article points out that this waste heat is a sign of a system under duress. If you have flickering lights when the AC kicks on, or if you hear a faint buzzing sound from your panel,
That's the sound of money burning.
that is literally the sound of money burning,
Yeah.
and the breaker tripping is just the final straw.
So if your breakers trip a lot, your system is basically screaming for help.
Screaming. But the silent waste happens constantly, long before that trip. And we really have to talk about the load aspect. The demand we put on a panel today is fundamentally different from what it was designed for in, say, 1996.
Oh, totally. In 1996, what did I have? A tube TV, a fridge, maybe a desktop computer I turned on for an hour.
And some incandescent bulbs.
Yeah.
The load profile was intermittent and low.
Yeah.
Today, you have multiple HD screens, always-on smart speakers, a Wi-Fi mesh network that never sleeps. You probably have a second fridge in the garage.
I do, and a work-from-home setup with 2 monitors running 8 hours a day.
Exactly. Hernandez notes that upgrading to a modern panel isn't just about adding more slots. It's about better thermal management, better conductivity. It's built for today's traffic.
So an old panel is like a 2-lane country road.
Yes. It works fine for a few cars,
Yeah.
but now we're trying to drive an 18-wheeler down it alongside a convoy of Amazon trucks. The friction, the stop and go,
That's the inefficiency.
that's the waste. A new panel is a 6-lane highway. The traffic flows without resistance. Less resistance means less heat, which means every watt you pay for actually does work.
So if your panel is hot or buzzing or your lights dim, you are paying a resistance tax on your electric bill every single month.
Correct. And that tax compounds.
Okay, I want to pivot to the future-proofing aspect because this is where it sifts from saving pennies to, well, potentially saving thousands.
Yeah, this is critical, especially for listeners in California where solar is almost standard now.
The Hernandez article has a whole section on this.
Right. And a lot of people approach solar backward. They buy the fancy panels for the roof because that's the visible part.
It's the sexy part of the purchase,
Yeah.
right? Look at my eco-friendly roof.
Exactly.
Yeah.
But Hernandez highlights this massive bottleneck that people forget. You generate all that clean power, convert it to AC, and then try to feed it into a 1980s electrical panel.
And what happens?
You run into serious limitations. The panel is the gateway. If the gateway is too narrow, you can't effectively use the power you're generating. It's called backfeeding.
Explain that.
When you have solar, you're pushing power into the panel to be distributed. Old panels have busbar ratings that physically restrict how much solar you can backfeed.
So you might buy a huge solar system, but the electrician looks at your panel and says, sorry, you can only actually use half of these.
That's a real possibility. Or you have to do complex workarounds that cost more money. To maximize the ROI of solar, Hernandez says you need a main service panel upgrade. It ensures the energy is efficiently routed.
So you're not just leaving money on the roof.
You want that energy flowing freely, not getting stuck at the bottleneck.
Which brings us to the other big power-hungry device, the electric vehicle. The Copperfield electric material specifically lists EV charger installation. This feels like the ultimate stress test.
It absolutely is. Adding an EV charger is like adding a second small house to your electrical load. A level 2 charger can pull 40 or 50 amps continuously for hours.
For context, a standard raw outlet is what, 15 amps?
15 or 20. An EV is a massive, sustained draw. If you have a standard 100-amp panel, which was code for decades, and you turn on the AC,
That's maybe 30 amps.
the electric oven,
Another 30.
and then you plug in the car.
That's 50 amps. You're already over.
Instantly. The lights go out. Copperfield Electric emphasizes this because they see it all the time. People buy the new EV, they drive it home all excited, and realize they physically cannot charge it without shutting off the rest of the house.
That's a nightmare. Your brand new technology is being rejected by your house.
It is. The
Huh.
strain isn't theoretical heat anymore, it's functional impossibility.
Right.
A panel upgrade is usually the prerequisite for reliable charging.
There's a smaller detail in the Copperfield source I thought was interesting. They mention LED lighting.
Hmm.
It seems small compared to an EV, but they frame it as part of the ecosystem.
It's the other side of the equation. Think of it like a budget. An EV adds to your expenses your load. LEDs subtract from them.
Okay.
So if you lower your lighting load with LEDs, you free up capacity. Then you upgrade the panel to increase your total capacity. You're attacking the problem from both ends.
I like that. It's not just buy a new box. It's optimize the flow.
That's the ultimate money-saving combo. Efficient fixtures plus efficient distribution.
Okay, so we've established the why. Heat is waste, and you can't charge a futuristic car with ancient infrastructure. So let's get practical. If I'm listening to this, picturing that rusty gray box and thinking, okay, I need to fix this, who do I call?
And for listeners in Southern California, this is the deep dive into the local option.
Right, so we looked at Copperfield Electric. They're based in Tustin 1581 Copperfield Drive, but their service area covers the whole OC map. Irvine, Anaheim, Santa Ana, Costa Mesa, Newport Beach.
All of it. And I want to pause on why local matters here. We often just Google electrician and click the first ad.
Sure.
But in the service industry, proximity equals response time, and it often equals accountability.
Because they're neighbors, not driving in from 3 counties away.
Exactly. Copperfield is a family-owned business. And in my experience, those businesses often have a different level of pride in their work. The name on the truck means something.
That makes sense. And speaking of their staff, the source says their electricians are background checked, bonded, and insured. They list their license number, hashtag 1094740. Why is that number so important?
You absolutely have to check it. The Hernandez article warned about this. Panel upgrades are best left to professionals.
So no DIY.
Absolutely no DIY. And honestly, no handyman special either. If someone does unpermitted work on your panel and God forbid there's a fire later, your insurance company can deny the claim.
Oh, wow.
That license number is Copperfield saying, we are legitimate, we are insured, and your home is protected.
That's a huge point. It's about liability. But there's one differentiator that really stood out to me. They call themselves a 24-hour electrician.
That's critical.
It is, because house disasters have a cruel sense of irony, right? The power never goes out at 2 p.m. on a Tuesday.
Never. It's a universal law.
It goes out at 9 p.m. on a Friday. Or the AC blows the breaker at midnight during a heat wave.
Or you smell burning plastic on Thanksgiving morning.
That smell is the scariest thing.
It is. And this is where the 24/7 promise matters. Copperfield's tagline is, you've got enough worries, let us take care of the lights. They're acknowledging that these aren't just inconveniences, they're emergencies.
So it's about peace of mind,
Yeah.
knowing that if I call 626-622-9694 at 3 in the morning, a person picks up.
Right. And they back it up with a 100% satisfaction guarantee. It's about trust. Their other tagline, let us fix it so that you can focus on what you need to do.
Yeah.
That really sums it up.
Okay, but I want to push back a little here. We're talking about all these benefits, but we have to talk about the elephant in the room, the cost. A panel upgrade is not cheap.
It's an investment. No getting around the upfront capital. But let's look at the economics through the lens of the Hernandez article. He frames this as cost versus investment.
Okay, break that down for me. How do I get my money back?
3 buckets. First is the monthly operational savings, the reduction in waste heat. That's a slow drip, but it adds up over 20 years.
Okay.
Second is property value. Hernandez states that an upgraded panel increases market value.
That makes sense. If I'm buying a house and the inspector sees a brand new, clean 200 amp system, I check that box mentally. Okay, don't have to worry about that.
Exactly. It reduces friction during a sale. But the third bucket, and I think the most important, is preventative savings.
You mean preventing things from breaking?
Yes. Power surges, voltage sag, arcing that can damage sensitive electronics, your smart fridge, your fancy TV, your HVAC control board.
Oh, man.
Replacing a sub-zero fridge because of dirty power is way more expensive than the panel upgrade would have been.
So it's insurance, like replacing the timing belt on your car? You hate paying for it, but you do it so the engine doesn't explode next week.
Perfect comparison.
Yeah.
And this leads to a specific policy from Copperfield Electric that I found really refreshing. They talk about competitive pricing. Sure, everyone says that.
Right.
But they explicitly say they are honest electricians who will only diagnose a problem if it truly exists.
The dreaded upsell.
Exactly. We all have that fear. You call for a flickering light, and suddenly you need to rewire the entire house for 10 grand.
Yeah.
Copperfield's stance is diagnostic first. If it's a bad breaker, they replace the breaker. They only recommend the full panel replacement if the data shows it's necessary.
Honest diagnosis. That builds a lot of trust.
It empowers you. You know you can get them out there just to look without committing to a massive project.
So let's bring this home. If you're in Orange County, Tustin, Santa Ana, Newport, anywhere in that zone, and you're seeing the signs,
The lights dim, the panel buzzes.
or you just bought a shiny new EV and realized you have nowhere to plug it in.
Or you just want to stop wasting money heating up your garage wall.
Right. You have a resource. You can reach out to Copperfield Electric. They offer a free quote, which is a no-brainer first step.
You can call them at 626-622-9694. That's 626-622-9694.
So, to recap our deep dive, we started with a high bill, and we found the invisible culprit.
And we learned that upgrading your electrical panel is a threefold strategy. It stops energy waste, it unlocks future tech like solar and EVs, and it protects the value of your home.
And we learned that if you're in Southern California, you have a partner in Copperfield Electric. Family owned, licensed 24/7, and committed to fixing only what's actually broken.
It's really about making sure the infrastructure of your home matches the lifestyle you're actually living.
I think that's the key takeaway. Don't let a 1980s metal box hold back your 2026 life.
Before we go, I want to leave our listeners with one last thought. We obsess over the visible things. We nag our families about the thermostat. We switch off lights to save pennies. But we completely ignore the respiratory system of the house.
Mm-hmm.
Ask yourself this. Is your house fighting against its own electrical grid every time you turn on the microwave? And how much is that invisible fight costing you every single month?
That is a scary thought, but a necessary one. Go check that panel, everyone. Thank you for listening to this deep dive.
Take care.
See you next time.